Hi there and welcome to the new tutorial where we will going to discuss the k nearest neighbor algorithm, a simple yet powerful algorithm. So in this tutorial video you will going to look at how this calculation or this algorithm really work and the calculation related to it in a very simple fashion, and then we will see its implementation in the Python with a real-time data set. Alright, so how this algorithm works. So it has k nearest neighbor. As you can see, the algorithm name itself is the k nearest neighbor. That means it looks at the observations which are neighbor to each other, and then when we provide a new observation, then it classifies as part of the same neighborhood. So what do I mean by that? Let's see it in the presentation format. Okay, so let's say we have this data set where let's say we have profit over here and the sales over here, or any dimension. But what I really wanted to show you is you have some data points over here and some data points over here. As this is a very simple example, what happens if I put a new data point, let's say over here? So one can very easily identify that since this data point is closest to these data points, we will going to classify under this. Now how this is happening in our mind is based on the distance between these data points to this data point. So from a common sense, we can clearly understand that since it is closest to this data point is closest to this data points, then we will going to classify the new data point as part of the neighborhood of these data points. And that's basically how this algorithm works. It's based on the distance. And what it checks is the distance from this data point, this data point, this data point. If we have classified this as one neighborhood into our algorithm, which our algorithm expect that how many neighbors you want as part of the one group. So we classify, let's say, 3 data point as part of the one group, then it will see that this particular point is part of this neighborhood or this neighborhood. If let's say we have another data point which is over here, then this new data point is part of this neighborhood, which is 3 data points. And that's how we basically internally tune the algorithm by first starting with the 1 data point to 2 data point to 3 data points. We start increasing the number of data points and identify where we are getting the best accuracy. So right now we have 3. Let's say after this addition of new data point, what we are saying to our algorithm that now we know the new data point, then classify or group them as part of the 4 neighbor. So KNN equals to 4, or the number of neighbors we will going to provide 4 in the algorithm, which I will show you in Python. But what I really want to show you is this next step. So over here, if you see, if we have a data point like this which is closest to this and this as well, so how you will going to classify? Now in this example, when we were here, I said that we want to say that neighborhood is part of 4 data points. So this and this data point is part of one neighborhood, and similarly these 4 data points are part of this neighborhood. Now if we look at this new data point based on the new neighborhood that we have created after identifying new data, this data point is closest to this one. Why? Because if you see, this data point is only closest to this point of this entire neighborhood. However, if you see, this is far, this is far, this is far. But if you see, this data point is closest to this as well as to this. So in 2 scenarios, it is closest, this data point is closest to this particular neighborhood. So in this case, we will going to classify this particular new data point as part of this neighborhood. Now this is something very simple and very straightforward explanation by looking at very simple data points where we clearly know, okay, this is the first group, this is the second group. First, these are the number of neighbors are 3, Now we identified the new point and classified as the new neighbor. Now we have the new information that KNN equals to 4, or we have the number of neighbors as 4, and then we can classify the new information. Now think like if you are getting thousands and thousands of data points, let's say every hour, every day, or every week, then doing this manually really not going to make sense. And in that scenario, what you really need is an algorithm. So I will go to the algorithm, how it happens, but we will going to further solidify our understanding how this really works. I will going to show this example what I have put it over here in the spreadsheet format, because after that it will be crystal clear, and you would be having a good idea about how this algorithm really works, and in backend what really the calculation happens. Alright, so after that what I have is by default, if you don't provide any distance related method, which I showed you that it calculates the distance, then it uses the Euclidean distance to calculate the distance, and the formula for that is xi minus yi and square root, and square and entire thing is under square root. So what does that mean? We have the new observation minus the old observations that we have. We'll take a square of it and do a underscore root of that. So let's see this in the Excel. Alright, so here I have a very simple data point or the data set which I have shown you in the slide as well. What it has is basically one part of sales. If you see, this is one group where the information or the sale is closest to somewhere around 2000. It's 2200, 2500 and 2000. And over here we have the lower sales value. So if you could recall, we have the values which are at the downside. So let's say if I have a new value which is 7 data point, and over here I got it like, let's say 1000 is the sales value. Now where would I classify? Let's say you have hundreds and thousands of rows. How would you really calculate that where it is closest? So in that case, what we are going to calculate is the distance formula which I showed you, and that is if I take equals to SQRT, because we need to take the square root of the entire value, and what we need is first value minus the last value, the first value over here. So this is the new value which we have inserted, let's say as an example, and this is the existing data set, that data point that we have. So close this and take a square of this and close the entire formula. Alright, what I need is one more bracket. So if you see, think like this, B8 is nothing but X or the new data point. B2 is nothing but the Y, the new data point. We are taking a square because that's how the distance calculation is, and based on the output we are taking the square root of the entire output. So if I enter this, you get 1000, right? So what do we need? We want to fix this position, because if I drag this down, this value will also come down. So B8 need to be fixed. So if I press F4, it will be fixed. Now if I come down and press Ctrl D, you will see that distance from this value to this value is what? 1500, right? Distance from here to here is 1200. Now distance from 550 to 800 to 1000 is 450, and similarly from 800 to 1000 the distance is 200. Now one can clearly see that this is the closest, so ranking 1, this is the second closest, ranking 2, this is the third closest, ranking 3. And if we are saying that our neighborhood or in our data set we have the 3 neighbors, then these 3 data points will come along with this data point, or this data point will come along with these 3 data point and will be part of this neighbor. So now you understand how this algorithm really works in the backend, and that is what is happening in the backend, that it calculates the distance. Wherever the distance is closer, it classifies it under that group. So what it does is it creates the neighbors and then classify the new value based on the number of neighbors that we are providing. Alright, so now let's go ahead and see its implementation in Python. And before I show its implementation in the Python, let's see the dataset itself. Alright, so here is the dataset where we have these columns, right? So the first column is nothing but the payment type, whether it's the payment, transfer, cash out, debit, lot of different categories that you have. The amount is the amount of the transaction in the local currency, and then the name of origin, customer who started the transaction. Old balance org is nothing but the initial balance before the transaction. New balance org is nothing but the customer's balance after the transaction. Name dashed is nothing but the recipient ID of the transaction. Old balance DEST is nothing but initial recipient balance before the transaction, and new balance test is nothing but the recipient balance after the transaction. And is fraud is basically the column that we want to predict. So that's basically identifies as a fraudulent transaction as 1. If fraud has happened, then 1. If it is non-fraudulent, then 0. And is flagged fraud is nothing but flags illegal attempt to transfer money more than 200,000 in a single transaction. So we will use this data set and try to classify the observation or try to predict whether the new transaction or the new value that you are getting, let's say the type of amount, the amount, the old balance, new balance, all of that, based on this, whether the transaction or whether the customer will going to do the fraud or not. Alright, so let's go to the Python. Okay, so here I am in the Python, and if you see, this is a Jupyter notebook. Oh, why it has opened? I'll just cancel. So what I really wanted to do is I want to increase the font. So now it should be properly clear, and I will just hide this. So toggle header. Yeah. So now what I'll do is, first of all, I need to import the data. So what you usually see is, in my case, the way I explain is I will going to import the libraries as and when it is required. But in most of the tutorial or most of the other examples you must have seen, there is a long list of libraries, and sometimes I feel that it's very hard to follow because that looks like very daunting or very hard thing, that's something really hard we are following, but that's not it if we split it in a proper way. So I will going to import the library as and when it is required. So first thing what we need is the pandas library. So I will import pandas as PD. Alright, now let's look at the data. So we have the data stored over here in the CSV file, and it's stored over here. So if I execute, it's a very huge file. It has, I think, more than million rows, and it's 485 MB file or something. So what you can do is I'm providing you this entire data set. You can find it in the description and use it. But going forward, what I'll do is, since it has a lot of data and it will going to take every time whenever I will execute a command, that will going to take a lot of time. So I will reduce the data set. So first of all, let's see the columns and some information about the data set. So here we get the column. So what it has is 6 million rows over here, and these are the columns: tab, type, amount, all of those columns we have seen, and then it shows how much memory that we have used. Right, so that's also sometimes very useful, whether a particular data set or the function or the expression, how much memory it is using. You can calculate that and then utilize it. All right, so once we have this, first of all, what we can check is how many fraud related transaction we have. So for that, we will say data is fraud dot value underscore counts, which will give us the count of values. So fraud has not happened in most of the cases, as you would see. So this is like 6.353 mil rows or 6.3 million rows, and in only 8,213 cases fraud has happened. So that's how you will usually find the data set which is highly imbalanced. As you would see, 99% of the cases the fraud has not happened. So how I can say that? Well, I can use this command again, and I will just provide the parameter normalize equals to true. So this will give us that in 99.8 or 99.9% cases fraud has not happened, and only 0.001% cases fraud has happened. So this is the way, if somebody is asking you or some interview question you are following, this is how you need to tell this information. Alright, so what I'll do is I will take all of the rows just to simplify this example and just to follow it along. I will take all the fraud transaction and I will take only 20,000 rows from the non-fraud transaction, just so that we can work it easily. Otherwise it will going to take a lot of time for us to execute the command. Alright, so for that, first what I'll do is I will take all the observation wherever the fraud has happened. So df underscore fraud equals to data dot is fraud equals to 1. So what it will going to do is it will filter only those rows where fraud has happened and store it over here. So if I execute like this, similarly df underscore no fraud is equals to data dot is fraud equals to 0, right? So straight away you have now got it, where the data has the fraud has happened and the fraud has not happened. And if you want to check, you can df underscore no fraud just to check. We can get the shape of this. So how much we get? 6354407, and that's what the value count was. So that means it has done the job properly. And similarly we can check the shape of df underscore fraud. So 8213, that means properly all the rows has come. Now if I want only the 20,000 rows, what I can use is very straightforward, head 20,000. That means I am going to pick only the first 20,000. Now this is very controversial topic, that how you want to select the rows. I'm using a very simple method that just give me first 20,000. If you want last 20,000, you can use tail, or you can use something like which is called sampling of data, which is normal sampling, stratified sampling. So there is a lot of things that we can do, and that's a controversial topic, like I said, because everyone has a preference over one or the other method. So I'm going by the simple way. So here I am executing. Now if I just check the shape of this data set, what I have is now 20,000 rows. Earlier it was somewhere around, it was 6.3 million rows. Okay, so now we have this information. What we need to do is we need to use the concat method to combine both of these data sets. So what we will going to do, data underscore subset is the new column which I will dataset object which I will going to create, and I will say pd.concat to concatenate both the data set. So df underscore fraud comma df underscore no fraud and access equals to 0. All right, if I execute now, it should have 2813. So 20,000 rows from here and 8213 rows from here. So if I just check the shape again, 28213. So far so good. Now let's see some data visualization or data exploration. So for that, I will import the relevant library, which is cborn as SNS. If you don't know cborn, I have lots of good videos posted about the cborn, each step by step and very much in detail. I highly recommend that if you want to do the data exploration, data visualization, you see that. Okay, so first of all, let's plot a bar plot to understand the payment by type. So sns.bar plot, we will say x equals to type. If you don't know the columns and you want to get it, so what I can do is you can data underscore subset dot columns is the command which you can do, and you will find all the columns information. I find it very useful whenever the data set is long and I don't have to remember all the columns name. I can just simply run this command and it will give me all the columns. So x equals to type, y equals to, let's say we want to take amount, and after that we want to specify the data, and which is data underscore subset. So it will going to produce a plot for us, so which shows that most of the transaction is happening by transfer, then cash out, payment, debit, and cash in. So these are the amount by value. All right. Now after this, you may want to see the amount by the fraud. Okay. So Control C, Control V. So now what I need to just say is hue equals to is fraud. If I execute this, you will see a fraud legend has come where blue indicate that fraud has not happened and 1 indicate that fraud has happened. So you will see that in most of, or in these two cases mostly, the fraud has really happened in case of transfer and in case of the cash out. All right. Now let's see its distribution as well. So I will use the box plot to get the distribution, and I will say x equals to type and y equals to amount, and then data equals to subset. Sorry, data underscore subset. So if I execute that, you will see only in these two cases we have lots of outliers, right? And now by now it's pretty clear that these two categories are really contributing in terms of the most of the transaction, but most of the fraud as well, right? So this is a very good information which you would really like to show to your end user, that how the information is happening or how the fraud is happening and in which categories the fraud is happening. Now let's one can really explore a lot, because we have if I say data underscore subset dot head, you have lots of columns. We have just explored type and amount, and you can see that we now have a lot of information that which category, in which categories most of the transaction, most of the amount is happening, and which categories are responsible for most of the fraud, as well as in which category we have most of the outliers. Similarly, you can experiment with the name array, or sorry, not in these columns. This is not relevant. This and this, these are just the unique identifiers. But old balance, new balance, old balance, new balance, create a correlation matrix and just see how the values are really happening. So I would really recommend that you see my SNS tutorial if you want to further explore the data and see what observations you can come out with. But what I'll do is I will going to start the some of the process related to the machine learning. So first of all, I will going to check the data set type or the data types. So if you see, the data type over here is the object. One of the important column is type. By now with the data exploration we can clearly figure it out. And these two columns, name oric and name dast, is really not very valuable. So we will going to drop these two columns since they will not going to contribute much. These are just the unique identifiers, and we will going to create a dummy values or columns based on these type column. So first of all, we need to convert this into a category. So what do we need is over here data underscore subset, and it is type equals to data underscore subset type, and to convert the type we will say as type category. So now this is changed to category. If you want to check data underscore subset dot info, so now it is a category, because this is by converting into categories we can then convert it into the dummy variables or those variables which machine learning can understand. All right, so earlier it was object, now, or a general object, now it is category. Let's drop the columns which we don't want. So data underscore subset equals to data underscore subset dot drop, and says name ORIG, name DEST, and we also don't need the is flagged fraud because those are just the observations from the data set and really don't provide a lot of contribution. You can explore a lot if you want to explore, but this is something which is not providing a lot of value when you will explore it. So access equals to 1. All right, data underscore subset. Now we have this. Now what can we do is there are a couple of methods by which you can really do the changing the categories, the type categories into the columns. Like for example, if, let me just show you data underscore, which is much easier way. So these text value is something which machine learning won't understand, or the machine learning algorithm will not understand. It only understand the numerical values. So to convert into numerical values, there are something which is called as one hot encoding or creating the dummy values. So what it does is it encodes the value transfer as 0, cache out as 1, and rest other categories as 0 and 1 based on whether they part of this category. So for example, for row 2 the transfer will be 1, but rest of the other categories is 0. For row number 3, cache out will be 1, saying that yes, it is by cache out. So how we can create it is, I'm showing you a very simple method which is part of the, what do you call, the pandas dataset. So let's see that how we can create it. So first of all, I will just create a new variable type dummy so that I can store all the new values which will be having out of this column, and I will use pd.getDummies function, and I will provide the data set, first of all data underscore subset, and then the column name, that on this data set, on this column, we want the dummy values and we want to prefix it by type. All right, so now if you see type underscore dummy dot head, this is how it has changed the value. Type cache in, right? So cache in is not present in any of these rows, but if you see the transfer, right, transfer is present for the row number 2, so only transfer column has the value 1 and rest of the column is 0. This is a very important data step. So whenever the question is that how you will use the categorical variable or the text values which are categories in the machine learning, that's how your answer will be. Okay, so once we have this data set, what we need to do is join it with the main data set. So pd.concat data underscore subset comma type underscore dummy and access equals to 1. We need to add the columns. So if I execute, that's how it is. And just to check, data underscore subset dot head you see that this has not happened, right? So what do you need is a simple thing, data underscore subset to this. Now if you see the head, this is how the columns have been added. All right. Well, after this we can start some of the machine learning tasks, because if you see all of the columns, we have it over here, which we needed. Now we need to just start creating the x and y values. So our x is data underscore subset, and we need to just drop couple of variables, which is fraud, comma, type. We don't need is fraud, right? We don't need type because we have already converted it, and we don't need step type. We don't need step, right? And axis equals to 1 dot values, because we need arrays in that. So what it will do is it will going to drop all of these values, and for rest of the values, which is amount, old balance, and rest of the column, it will give the values. So if I just execute this, you get the x values. Now y is data underscore subset dot is fraud dot values, because is fraud is our target column which we want to predict, right? Now let's create the train and test data set, which is an important one. So from sklearn dot model underscore selection import train test split. All right. Now we will going to specify x train underscore x test, y underscore train underscore y underscore test. So these are the splitting of data set into train and test, so that we can learn, or we can train the model on training data set and then test it on the test data set. So x comma y comma test underscore size equals to 0.3, and then random underscore state, so that if you produce it again using the random state as 5, it will give you the same output. And then we have two ways by which this particular method, sorry, I have not specified, train test split, it does the sampling of data based on two ways: normalize if we don't specify anything, and there is one which is stratify equals to yes, which makes sure that those values, the target value is well represented in the training and testing data set, so that we get the right output. So stratify equals to y. If I execute it, you get these four variables: x train, x test, y train, and y test. Now let's import the library from sklearn dot neighbors import k neighbor classifier. All right. KNN equals to, we will initialize this k neighbor classifier, and as I mentioned over there, we will going to start with the 3 neighbors. So if you can recall, that's what we did when we specified. So n underscore neighbors is 3. If I initialize, now the object has been created. If you just see KNN, it says algorithm equals to auto, leaf size equals to 30, lot of what is the metric that it follows, number of jobs, neighbors, p equals to 2, lot of variables, but one of the important variable is how many number of neighbors. However, if you want to know a lot of this information, then you need to check the documentation, because it requires altogether a different video for at least 2-3 hours to go through these. Alright, so after that, what I can have is knn.fit, and I will fit the algorithm on the x train and y train data set. So once we have this thing, knn.fit x train y train, This is the output we get, similar output what we had it over here. Now if I want to know what is how much or how better the algorithm is predicting the values, then I need to use the test values. So KNN dot score, and I will use the test data set to see the score on the unseen data. So what we have done, we have trained the data on the training data set. Now we are supplying the unseen data set to the KNN algorithm, and let's see what accuracy score we get. So in just one go with not much of a tuning, you see that in 97.96% with that accuracy, we are getting the predictions based on the test data that we are supplying. That means we can safely say, at least at this point, based on the data set we have, that 97 or 98% is basically the accuracy rate that we have with this particular algorithm, which is quite nice. But generally that doesn't happen when you look at the real data set, because real data sets are really messy, or if we have used all the rows which is highly imbalanced, we could have got a lot of probably a worst result, maybe somewhere around 30-40% accuracy. I'm just guessing, but you can try it out in your own time. Since we reduced the data set from imbalance, it become highly available with the good number of rows which is showing the fraud. That's why we are able to get this result. So nothing which we should be proud of, but at least what we know is how to run the algorithm. But what I really recommend that you go ahead and run it on the entire data. All right, after that, one thing we will going to do is tuning the parameters. So how we tune the parameters is by doing the grid search. What it does is it searches the best parameter for us based on the parameters that we are specifying. So let's say we want to search what is the best number of neighbors. So in that case, we will create one grid search variable gs, and before that I need to import the grid search algorithm as well as the numpy. So import sklearn dot model underscore selection, sorry, from this package, import the grid search cv and import numpy as np, since we need to create a range of values for the number of neighbors. So with that, for which variable we are creating an underscore, so this is the dictionary that we are creating, and underscore neh neighbors, why it is coming again, underscore neighbors np dot range 1, 25. Let's say we want to search between 1 to 25 for the number of neighbors, whether 3 is good, 5 is good, 10 is good, 1 is good, which is the good number for the grid search. And this algorithm takes a lot of time, so be aware when you are applying on the entire 6 million rows, because I'm sure that will going to take the somewhere around 2-3 hours, at least based on what configuration what I have. So if I execute this, it's executed properly. So KNN underscore gs, I am initializing the new classifier. As you can see, I am not specifying the number of neighbors because this is something which I will going to search. All right, so KNN underscore param underscore search is the new object I am creating to get the parameters. And now I'm specifying the grid search CV, where I will give the algorithm name KNN underscore gs, comma, the parameter in which it needs to search the algorithm gs, and CV cross validation equals to what, 10. So what cross validation do is it divides the data set, so based on the number that we are providing. So here in this case it divides the 10 data set into 10 small chunks. It will use the first 9 chunk as the training data set and 1 chunk as the testing. Once it will check the 10, then it will move to 9, and then from 1 to 8 and then 10 it will use it for the training, and then it will use the 9th data set as the testing. So that's basically a recursive thing, that out of 10 data set, one by one each data set is hold out for testing, so that you have the representation of all the data sets. So if I just press this, you get KNN underscore param underscore search done. It's very fast because I have reduced the data. Now let's fit the model based on the parameters that we have searched, x underscore train comma y underscore train. So like I said, it will create the 10 sets, and step by step it will use the 9 sets as the training and 1 set as the testing, and continue with that cycle. So if I execute, now this will going to take time because this was just the initialization. Now we are running the algorithm, and as you can see, with just 28,000 rows, I think it will going to take anywhere between 1 to 2 minutes. Okay, so I paused the video and it took around 3.5 or 3 minutes 30 seconds to get this thing to me. So now you can extrapolate how much it will going to take for the 6 million rows. A lot of time, and that's the reason I reduced it, this data set. So here a lot of parameters are present. So what we need is basically the best parameter, and that's what the name of the method is. So KNN underscore param underscore search dot best underscore params, and if I execute, so what we get is number of neighbors equals to 1 gives us the best value. Well, that would probably the case, because that is like saying that whenever you are putting a new data set, whatever is the closest data set, just use this. So ideally that's how it should, that's how one can really see, but probably not the best way of classifying your data set. So we will go whatever we have got, but just wanted to give you my 2 cents that number of neighbors equals to 1 is will always going to give you the best results, like almost 100% of accuracy, but that is like saying overfitting of data. Okay, so with this what we can also get is the KNN underscore param underscore search is the best score. So with this best score is 98.98, 98%, which was similar to when we were doing the earlier here. In this case also almost 98% we got, and when we tried to do some parameter tuning, we got number of neighbors as 1, but there is no much improvement in the score. So what I would go is mainly with this score, because this looks like much better representation since it is mostly the case of overfitting to me. So that's something which is more meaningful for me. Alright, so after this you can get, or you can create a new data set based on these values. So for example, over here x, so we have these values in x, but this is not readable. So what we can do is convert into a data frame, or it's basically the one set of rows, if you'll ask me. So because the algorithm takes the values in the form of the algorithm, that's why we have to convert it into an algorithm. So you need to provide the values into an array, some new values. So if I say over here data underscore subset dot head and just one value. So what do we have is basically the amount, the old balance amount, so on and so forth. So if we convert this particular value into an array, which is a very straightforward way if you are using the Python, then you can simply use the predict method to predict the values. So that is nothing but this. And over here within the array, just collate these values, whatever we have provided in the training set up until here, and then for these values, and you will get the output for the prediction. So that is an exercise that you can take for the purpose of doing the prediction. And if you find any problem, you let me know in the comments, because this is very straightforward. As I can show you, you just need to provide the values by comma over here. So that's about the entire case study for the KNN, and I hope you will be able to utilize all of this information into your real project. And yeah, that's about it, and I'll meet you in the new project with some new algorithm.